Which of the following numbers is the biggest? How would you determine the answer if you are not provided a calculator? More generally, let a and b be real numbers that are both positive. When would a to the power of b be greater than b to the power of a? This kind of questions often comes up in Cambridge admission tests known as sixth-term examination papers, as well as Oxford mathematics admission tests. Why they like to ask this kind of questions? Keep watching until the end so that you do not miss it. Notice that this question addresses on the power of numbers. We have a fancy function that is specifically designed for power problems. The function is logarithms. Since we know that logarithm is an strictly increasing function, this is equivalent to log of a to the power b is greater than log of b to the power a. Using the law of logarithms, this is equivalent to b log a is greater than a log b. The main goal here is that, instead of proving it directly, we prove this intermediate step. Then we go backwards to conclude the result. Now since a and b are positive numbers, we can rearrange it to log a over a is greater than log b over b. This means that if we can find a condition that this inequality is true, by noticing that the left and right side of the inequality have identical format, therefore it is reasonable to consider the function y equals to log x over x. Let us substitute some values in and look at its behavior. When x equals to 1, y equals to 0. When x equals to 2, y equals to log 2 over 2. This means that it has an overall increasing property from 1 to 2. When x equals to 4, y equals log 2 over 2 again. So we can immediately see that there is a turning point between 2 and 4. To find out the turning point, we differentiate y with respect to x. Using the quotient rule, we have an expression for the derivative. Turning point happens when derivative equals to 0. A fraction is equal to 0 only when the numerator equals to 0. So turning point happens when log x equals to 1, which means x equals to e. Since there is only one turning point, we can now conclude that there is no further turning point between 1 and 2. Hence y is strictly increasing when x is between 0 and e, but y is strictly decreasing when x is greater than e. Strictly decreasing means that when b is greater than a, we have log a over a is greater than log b over b, if both a and b are greater than e. This completes the question by following the reverse step as discussed before. So what have you learned from this problem? Whilst a strong mathematical knowledge is an essential to top universities like Cambridge and Oxford, this is not the only thing that universities are testing on. As you have seen, a problem on number theory can relate to differentiation, which is a different brand of mathematics. To be honest, interviewers are not expecting the candidates to identify this relation right away. Instead, they would like to see how candidates take a step and attempt to manipulate the questions, and come up with a possible solution. There is one more thing that they value on: mathematical reasoning. Reasoning is the process of thinking and explaining something logically. Every step in the solution involves a reasoning. Solid reasoning skills is the key ingredient to be assessed on in such admission tests and interviews. A good reasoning should be flawless, which means that there is no counterexample to the question. You are pretty much guaranteed to have this kind of hard problems throughout the whole course. However, the problem will always look impossible unless you make an attempt to solve it. When you fail, you learn from the failures and fix the failures. Think of this again. Is getting into Cambridge impossible to achieve? Is this a hard task? It will always be a hard and impossible task unless you take some actions to solve it. So why not subscribe the channel for more tips and questions like this? Meanwhile, you can click here for the previous video I made on Cambridge admission tests, which seems a little bit easy. Or you can watch this video that YouTube suggests. I will see you next time.